Yeah, this is the problem now. So we're going to wait for everyone to join again. But I'm just going to admit everyone. Sorry about that, guys. So my time had elapsed. I just hope what I'm saying is making sense to you guys. I just hope it's making sense because at first it became sound like it's a tough subject to talk about, but trust me, it will get easier as we go. Because I know you guys, what's important about the data center is you approach one topic, everyone is happy about it. You approach another, so everyone has their own special, what you call it, special field. So it's going to be easy whenever we reach your field, but I'm going to make everything as simple as possible. So yeah. So today I'm going to, it's mainly introduction. So on the power side, it's the one that I want to emphasize myself on. No, I was talking about fire, sorry guys. So on fire. So under fire, uh, it's real fire we're talking about. We are covering disasters. So you have things like uh, you have things like non-flooding equipment. All that stuff is being monitored by the fire stuff. So we're going to cover a lot of those things. Smoke, dust. Nowadays there's something called the uh, VESDA, which monitors dust. Because most server rooms they trip on dust, but not the VESDA. The VESDA won't trip on dust. You see. So I'm going to, like I was saying, I'm going to give a topic to everyone for the week, and we're going to discuss that topic, right, in detail every weekend. So during the week, everyone is researching because I don't want to tell you guys garbage. I want you guys to be ready for the information so everyone can be on the same page and understand what I'm talking about. And that's how I think works best. Other than I just dump information on you on stuff that you have no idea what's happening and try to read later, catching up will be very difficult. Rather than read ahead and just you have know of what we are talking about, and I'll try to simplify whatever you've read during the week to be as simple as possible. So I think that's the approach I'm going to use. But if you have other suggestions, guys, just post in the group and we can discuss about it. I'm a democratic guy. We want to be democracy, right? So those are the main components. So things like law, where they bring the law in, where they bring it. So everyone who is going to try and invest in a certain data center will bring their own lawyers, big guys with the suits, and they will be making sure that all these concepts are covered. And yes, we are paying less for us to be on cloud, but what happens if a disaster hits, right? That determines the location as well. So someone will be going and ticking all the boxes to say, okay, how is your power like? Oh, you're in Zimbabwe where you have 4 hours or 12 hours load shedding. So now we can't invest in your data center in Zimbabwe. Oh, you're in South Africa. Oh, okay. Let's say you have load shedding. What are you going to do? Oh, we have a generator that is this big generator that has this big capacity, big tanks, and we have access to fuel, so much tanks. If we can lose power for days, we can do that. Oh, okay, so fine. Okay, our UPS, oh, your UPS, how is your UPS operating? Okay, we have UPS at this and this and this, right? And they'll go down to common level now to say they'll be asking you about things like redundancy and resilience. So I want you to remember this equation. It's an easy one. So redundancy plus resiliency, right? Redundancy plus resilience is equals to reliability. So everyone looks at reliability. How reliable are you? Can we trust you, right? Redundancy plus resilience is equals to reliability, right? So everyone they'll pay for reliability. No, guys, I'm never going to lose power. I'm always going to have my cloud available for me, this much cloud available for me. And if things happen, unforeseen things happen, right? That's where these big guys are strong. If unforeseen things happen, we are going to pay you for whatever you've lost, right? So that's the basic about the data center. That's how big data centers are winning small ones. But if you go to America right now, people are converting their houses into data centers. That's how much data centers are mushrooming. So for a person like me and you, we only see opportunity. If we see something like that, because one way or the other, that guy is going to need a technical person to take care of his data center. They call them babysitters, though. Babysitters, you don't touch anything. You see something that is wrong, you need to be able to report it. But you need to report to your manager, stating the exact thing that it failed. Because they don't want to bring an electrician for a mechanical problem. So that will be on you. They'll say, no, this guy doesn't know what he's doing, right? So that's why us guys, we need to know exactly what it failed on our system. That's why you guys need to learn all the components in the data center in detail. We're going to go down to the basics. So for today, let me just look at the pointers I put down. Yeah. So redundancy, I'm going to start with that equation that I just gave you about redundancy, right? Redundancy just means if I have 5 kids, right? Or 5 cattle, right? Zinosungwa. If one and Pakusunga Mumbai, I need 4, right? And whatever happened to any one of the 4, there's always one Mumbai report to cover. That's the best way you can explain redundancy. There's always one, at least one, to cover for anyone that fails. So you have Mumbai 4, you have Mumbai 5, it's Nosungwa, and Pakusunga only need 4. So if one ikamuka Shirwara or Ikarasika, for whatever reason, I have another one. That's redundancy, right? You can have 2. So the more redundancy you have, right, the more competitive you are in the market, the more advantageous you are. You see, but you need to be able to explain redundancy and to see how effective it is, right? Resilience means whatever happened to my kettle, right? I know by my cut the ability for it to get back to fitness. So what are those things? How I make sure there's resilience in my kettle. I dip them every day. I keep them healthy food. So you make sure that you have redundant. So in a data center equivalent, you are always servicing your equipment, right? You're having the right temperatures in your data center so that your equipment is operating at the highest efficiency, right? So those are the redundancy and resilience. So if you ask what is resilience, it's the ability of equipment to fix its own problems or to come back, right, from a breakdown. And redundancy is I have 5 mombe dzinosungwa. So I always try to make it as simple as possible, explaining to amaxhosa ndinovaendera whatever they understand. Kumazimbo I know it's mombe, it's something that comes easy to mind and fast and easy to understand, because when we say most people we understand this stuff. Yeah, that's reliability. So everyone is selling reliability, right? That's how those big guys are being bullies in the market, because they're selling reliability. So you won't be able. Okay. So we don't have any mombe kusunga. We don't have anything. What we have, if it happens, guys, we're going to pay you for whatever you're going to farm for that day. You see, that's another part of security. So we're going to discuss again. I'm going to tell you again about the weather. But I know this is the most boring part. That's why even for me, I don't like this part of a data center. But you need to know all these small words, because they comprise what 25% of any question that you're going to be asked, right? Because they want to know if you know your stuff, you know exactly what you're talking about if you're asked, right? And we talk of PUE, power usage efficiency, right? It's almost the same to the efficiency we just described, but now we are looking at the efficiency in using our power, right? So a lot of inventions have been done to try and cut this power usage efficiency, but I'm going to explain to you, it's a very easy thing to explain, right? Power usage efficiency is just, the meaning is magetsi atatenga kuzesa, right? Magetsi atinotenga kuzesa pazuva. And tozotarisa kuti what is the purpose of our data center, right? Purpose of data center ichi tatichi IT equipment. That at the end of the day, that's what we want to use all our energy. IT equipment, which is mbeu dzedu dziri mumunda, ndo dzatiri kuda chete. At the end of the day, everything else doesn't matter. So we're trying to go at the end, right? So power yatatenga kuzesa yese pazuva, anditi divided by power ichashandiswa neequipment ye-IT. That's it. You understand? It's a very easy thing, but a lot of people don't understand the power usage efficiency, right? So the number, if it must be as close to 1 as possible. So you can never have this power usage efficiency as 1. No, it's not possible. Even other guys can argue now, but it's not possible. Why? Because you have cooling and heating. If you get interviewed for Switzerland jobs, the reason why Switzerland have been so successful in data centers and Sweden, all those cold places, is because they are cold already. And the equipment that was being manufactured before for using in data center, like switches, they preferred cooler temperature, right? So it was easy now. Before, it was easy to cool down than to heat up. No, it was cheap. It was more expensive to cool down than to heat up. Sorry, that was the also. But now technology is proving all this wrong. Now it's even easier to cool down, because they discovered that they don't need to have their data center operate at 25 degrees or 20 degrees anymore, because most of the IT equipment, even UPSs, they accept temperature up to 40 degrees Celsius. So the more you operate closer to that threshold, the more profitable you are. Because we're going to discuss this in detail, but cooling most of the time, cost more, because you need all those things running at all times. You can switch off lights, yes, load shedding, switch off your lights and all that stuff if no one is in the data center, putting all those sensor switches. Some electricians like us, we understand that very well. But cooling is the hottest topic, and I'm positive, we're going to spend maybe 3 weeks talking about cooling alone, heating and cooling. That's how important it is, right? Kuvanhu vakaita HVAC. On this one, you may be safe, but I guarantee you are not safe because you need to know more than fixing HVAC. You need to know how to explain the basic principles around that. My little sister, I think she's in the group as well. She did HVAC. But trust me, you won't know half of it. But you are comfortable with some of the jargon, some of the explanations, but I'm not scaring anyone. It's all going to be easy. There's no stupid question. Any question that you have, guys, just send in the group and I'm going to answer to the best of my ability. If I can't answer it perfectly, like we said, Panawakaita ma HVAC, Panawakaita most, they can explain it better than me probably. So it's a democracy. So you can never have one. So they will ask you in an interview question, it's one of the most questions. Can you ever attain your PUE of 1? It's just possible in theory, but not practical. That's the best question you can, that best answer you can give. It's possible, but Taura, we can talk about it and agree. Yes, we can hear you. Because for what reasons? Things like free cooling. Free cooling is possible. Most kunana kwedu kunana Zimbabwe, it's actually very possible. Free cooling. Free cooling is just taking the air, ambient air outside. Zimbabwe will never reach freezing, right? And will never reach 40 degrees. So we are safe. We can pump all the air. We just need to clean the air. That's all. And bring the air in the data center and get rid of whatever heat is being generated by the equipment. So cooling is going to be the bigger part of us, right? And most of the questions, they come from cooling. Data center, and most of the problems as well come from cooling. So we're going to cover a lot of components in cooling. But Nasi, if you are not bored yet, I'm going to cover UPSs because that's my special field. Like I said before, I'm a UPS engineer, so that I'm very comfortable to help. But I'm not going to make it as deep. I'm just going to help you understand in the normal language what the UPS means. Or with the easiest language I can give, right? So for a UPS, right? Let me explain the power side of a data center first. So we are starting with, I don't know if everyone can see me, but I'm going to draw a small diagram. So we're going to get we said we need to position our data center where there's power, mainly, right? Which is the main thing that is needed. That's the biggest resource that anyone needs. And another thing is we just need to be as far away from natural disasters as possible, right? You don't want to build your data center in a place where it always floods, right? Or you always have windstorms now. Yeah, there are better ways to protect, or earthquakes. So you want your data center where there's no natural disasters, because no one can really predict them or know how to fight against them. That's why natural disasters and power. So like I said, most data centers before were being built in cool areas because the technology back then was a data center need to stay at 18 degrees, 25 degrees. But that's not the case anymore. Nowadays, the data center just need to be under 35 degrees because they say the intake, when mepo ichipinda chitorwa pa nemafenzi ichipinda mudata center inogaina only 5 degrees. So kana ikapinda iri 20 degrees inobuda at 25. But if ikapinda iri 20 degrees ichibuda at 25, we are losing a lot of money in power in my air conditioning system because my air conditioner ingafana kumanya all time. My chiller is running, so that's power we are losing. That PUE we talked about, right? And so for that reason, we need to ramp up our temperature for the chillers. Cooling again up 25 degrees, for example, or 30 degrees. You would have 35. We are still under the 40-degree threshold. So now most data centers that you see mushrooming data centers in the Kuma Arab, a lot of them now because of this reason, because they don't need to stay 18 degrees anymore. They can be as close to 40 as possible, as long as the 40 degrees that is coming out, the air that is, which is the exhaust that is coming out, is not 40 degrees. They are happy. Equipment is happy. So trust me, cooling and heating is going to be the challenge, because if you ask me, that's the data center. Okay, so power, we're coming from ZESA, we're using ZESA coming into a data center, right? There's equipment. This one you need to note it. You need to listen carefully here. We're coming with ZESA into our data center, right? And there's other equipment that uses ZESA directly, right? Like you may have some of the lights outside, right? Perimeter lights, right? That uses power, ZESA. If they switch off, it's not a problem, right? It's all right. But maybe you are staggering them differently, right? Then we go down, we take power, goes through to the generator, emergency power, right? We're going to talk about the STSs, or just a generator changeover circuit. That's, for most people know how to wire those and everything. I'm not going to talk about how wiring them, but I'm going to talk about how they are being used, because for big data center companies, that's where they monitor. For most power engineering, that's where they monitor. The BMS thing that we talked about, they monitor it at the changeover circuit. So it needs to be smart and compatible for any system that the data center chooses, or any program that the data center chooses to use. So changeover switch, or STSs, we are going to talk in detail about it. And so because that's the point of monitoring, right? So power goes to the changeover switch, and the changeover switch, it will go to the generator, right? And generator feeds, the other side feeds the UPS, right? And so it comes as one, right? One. Then changeover switch. I don't know if everyone can see. I'm not good at drawing. Okay. Everyone can see. So comes down, power comes in, right? Comes in power, and it goes to, there's a changeover switch, which is this one. I put a circle around the changeover switch, right? And the selector switch, whereby if it's no more power coming in, it's there, right? And if this power is gone, this one just switches down. It might be vice versa, but I'm going to fix it. This is where most of the questions about power come from, right? You need to be able to explain what happens when power goes out. So I'm gonna power in that generator changeover switch. We'll select, most of them now, changeover switch and the generator controller is one thing. For most generators that are being made now, it's one thing. So the generator controller starts the generator, stops the generator, controls the changeover switch. So most of the time now it's one thing. You won't find a fancy controller on the generator. You will find the fancy controller on this changeover switch. That's the one that will be controlling the generator. So power comes in, normal power is going through this side. If power goes out, generator takes over, feeding the UPS, right? So no matter how good your system is, I've worked with systems that was before, if we talk of generators, they used to start maybe 5 seconds, 10 seconds later. Not anymore. That's how smart these systems are these days. They start within 1 second nowadays, right? So that you don't need big UPS batteries, but I'm going to explain that in detail on how much time we have. I hope we are not bored, guys, but this is the part where they ask you to explain. I'm going to explain it in the easier language, right? After I'm done talking about this so that everyone will understand later. Power goes off, generator starts within 1 minute. Most of them, let's just say within 30 seconds, but it's always within 1 second, it checks. It's always synchronized, so it knows when to start. So these smart systems that they have these days, they're so fast, they start so fast, right? So you don't need big batteries for UPSs and stuff. Backs up until power comes back, and there's no interruption. So this big guy we talk about, the UPS, is the one I'm going to talk most about. But after I explain how this thing works. I'm sorry if we have other guys who are in the really pure, because there's some of the things I will go back to Rurimi Rwamai. For example, we have it in easier language for those who are not electricians. Changeover sequence works like this, or UPS NEMA generator works like this. Tinotora mvura yedu from Lake Chivero, right? Inouya ichipinda mufactory medu, anditi. But painouya ichipinda mufactory medu mvura, we need to first filter it, right? Tobvisa zvimatsvina dzese dzichiuya nemvura, everything tozvibvisa. Toidira chemicals, anditi, mvura iyi, pour chemicals in the water to try and clean it, right? On a chlorine, on a lot of other chemicals that they put in the water, right? It's not drinkable, right? Not at all. Then we store. Do you know that we store that water, which is chemicals? We don't store fresh water, right? We store that water in chemicals so that tanks. If you go to a water treatment plant, unozoona kuti vanotochengeta mvura iyoyo yavanenge vadira machemicals kuti isarambe isaora, kusaita mazengerere green aya, and that's how they keep it. Yabva ipapo mvura yochienda next stage yekuchibviswa machemicals, filtration again and everything, yozonopinda payatonoshandisa kufactory. Explain UPS ipapo. That's how UPS works. Saka panouya mvura ichiuya tomboidira machemicals and stuff. I'm explaining a rectifier, right? Mvura iyoyo haimwike yadirwa machemicals inouraya. That's the power that comes out of a rectifier or booster. Nowadays, it's called a booster. Haimwike mvura iyoyo inotouraya inenge ine machemicals. So our equipment cannot take DC voltage that comes out of the rectifier. You understand? So, and you know what we keep? Mvura yamatenga nambotaura anenge ane mvura yakasviba tochengeta yekuti kana mvura tazoona kuti taita problem yepipe, system yedu yaita problem kumusoro kubva kuchivero, tinomboshandisa mvura yatinayo, handiti. Tinomboshandisa mvura yatinayo mumatengi medu kusvika pipe yafixwa. I'm explaining my batteries, handiti. though my batteries are stored also in my tanks, right? We cannot keep AC. We can only store DC. That's the dirty water in my chemicals, and I'll explain. And if power goes out, our UPS, now that one I know everyone, even though you're not an electrician, you understand. They need batteries, battery run it. That's the power, but we cannot connect our equipment directly to the batteries. That's the same. We can't drink that water that is contaminated, that is chemicals. We convert that power first with an inverter so that your equipment can use it, right? Things can be said for all data center systems which used to use DC voltage, so they only have rectifiers. You go in there, you find big banks of batteries, so they're just using DC voltage. So most of them were 48 volts DC, so their switches were all DC voltage. There are still some that are operating that way, but now everyone is moving away from that because of the efficiency story we talked about. They are not efficient enough, right? So basically, that's the UPS I explained to you guys. I'm going to go to the technical terms about the UPS that they want you to answer. So I hope everyone is understanding what a UPS is in that part. So the generator, if you have to explain a generator, it's just that thing, that dam, local dam. Let's say you are a rich guy, unoitoka dam kako kaunoita pa area pako ipa. Kaunochengeta, handiti. Kaunoti kana pipe yehuku yabhesta kundomboshandisa mvura yangu yandakachengeta yemukadhemu kangu. It must be in a dam, not mumatank, because mumatank inenge yafanira kuiswa machemicals and stuff kuti chengete. Inenge iri mudhemu. Kana yabuda mudhemu imwe inopinda nesame process iyoyo yekuti totanga tamboicleana futi because yafanana neiri kubva kudhemu ruku. That's the generator. I've just explained the generator thing. So if you have to explain, if you understand it better, then if you have to uzochinja nechirungu chako wotaura kana wabvunzwa mubvunzo wekuti what is a generator, what's the purpose of a generator. It's just a local dam that we have at a premise, a dam, not a tank, that we have at a premise that can give you water. It cannot be too big, it cannot be bigger than Chivero, but it will give you water for that time kusvika mapipe afixwa. Mvura kana yabva kuchivero inombofeeda first too sometimes. So I hope I explain the concept, the basic concept. So hakuna stupid question. I'm going to answer every question that I'm asked. You can start sending your questions right now to WhatsApp. I've never used WhatsApp calls, but if people want it, we can always try it. So the WhatsApp call, a video call, I saw it, I just downloaded it today. So we can try it as well if this is becoming a bit tough. So that's the explanation of a UPS, general layman's language of a UPS, the process, how the process works from up, ESCOM, transformer. So we're going to cover transformers, a little bit of transformers, a little bit of switching, a little bit of bus bar layouts, because that will count as well as my redundancy. Atambotaura nezvayo tichaitaura in detail. I think we cut in any time. So I hope it's not too much. Or otherwise, let's stop here and cover this next part tomorrow for the UPS, the deep explanation of UPS and Machine Power Feedback. With how were you understanding what I'm trying to explain, or if I must change how I explain? Because yes, I've been teaching a lot of people before, explaining a lot of things before to a lot of different people, but maybe you a certain way of explanation. I know other people who know this information already. They feel like, nah, this is nothing, but trust me, it will get you. Because no matter how strong you are, the data center questions, they are not easy. You can ask the few that went through the process. The process is not easy. So the first will be I'm going to explain the process of the interview question. So the first will be a technical question, normally with your manager. He's the one who's going to ask you technical questions about everything and anything in the data center, right? You are happy, you are done. He's happy with you, you go to the next stage. So next stage, before COVID, it used to be done on site. So if they are happy with you, they may take you like to Germany or to US, pay your visa, we go to whatever, Switzerland, pay you for a visa and stuff, visitor visa. You go there, everything paid, hotel paid, you go there. Then you're going to have an hour with each manager or with each interviewer, right? Asking you about these things that we are talking about, that fire, right? So fire or only fire question, most of the fire questions. Also my behavioral questions. They are very strict about behavioral questions. They want to know your behavior, your attitude, how you approach things, right? Then you find someone who asks you about health and safety. So I'm going to cover a little bit about also health and safety for everyone to understand the approach, the question that they ask, and behavioral questions as well, how to answer those questions. They use what they call the SMART method. I'm sure most of the people know now about the SMART method, but after we're done with this, any interview that will come in your life, you ace it. That's what I can promise you. Then we have someone who asks you about the electrical part. Then we have someone who asks you about the mechanical part. So this is what happens. If a guy is mechanical and they try to ask you mechanical questions, I've encountered this. He tried to ask you mechanical questions, or maybe the manager. You answer all the questions and you embarrass him. So more often than not, you may embarrass the person that is asking you questions, right? You come hard on you on mechanical questions. So that's why you need to know a lot of mechanical questions. So mechanical questions, they talk of pumps, right? Chillers, they talk of psychrometric chart. I'm going to break it down for you, the psychrometric chart. And I'm sure everyone is going to understand that as well. So all the topics that I've listed in the group, if everyone has seen them, I'm going to cover them here. So today, I know this part is a bit boring because I need to give you direction on where we are coming from and where we are going. So when you are done with all the questions, and they'll ask you for real life examples. You cannot use one example. For example, nokuti chimbotudzawo shamwari musi wakafeila iwo. Tell us about a day when you failed at your job. You cannot say I've never failed because they know everyone fails, right? You need to find a way, find an example. So you can't use the one example on all of them because when they're done, they'll put all their responses. They have a meeting and they see what happened. If there's something that they're not happy with, they'll call you for another interview again. So that's why I say it can go from 4 hours to whatever they want until they are happy with you. But 1 minute left. So guys, it was a good day. So if you feel like you are happy with whatever I presented, let's talk in the group and update in the group. Thank you very much, guys.